Hello and welcome back. Welcome back to the second lecture on number pattern. We are reviewing some nice past paper questions in these series of number pattern videos. Let's look at this question that is from June 2012. It was a simple question except for the last part, which was kind of tricky. Now the question says the first four lines of a pattern of numbers are shown below. First line, that's 3 square minus 1 square. Now, before I proceed, understand one thing in mathematics. Do not look at the whole question at once. If I'm reading out the first line, I'm just reading only the left-hand side of that equation. First line is 3 square minus 1 square. I'm not moving further. Second line, 5 square minus 1 square. Third line, 7 square minus 1 square. Fourth line, 9 square minus 1 square. By now, you would have developed a pattern. You know that after the negative sign, there is a 1 square always. So that's kind of fixed. But in the first line, it's 3 square. Second line, 5 square. Third line, 7 square. Fourth line, n square. Fifth line, 11 square. Sixth line, 13 square. Seventh line, 15 square. Eighth line, 17 square, and so on. So you get a series of odd numbers starting with 3. Okay? Of course, again, it's an arithmetic progression, commonly known as AP. Write down the 7th line. That would be easy. Write down an expression in terms of n to complete the nth line of the pattern. Again, the same thing, Tn, the very last term. Now, let's focus on the right-hand side of the equal sign. In the first line, that's 8 into 1. Second line, 8 multiplied by, in bracket, 1 plus 2. Third line, 8 multiplied by 1 plus 2 plus 3. Fourth line, 8 multiplied by 1 plus 2 plus 3 plus 4. What we are discussing in this basic O-level math number pattern question is that to give you a sense of numbers, a beauty of the pattern that lies in these numbers. And of course, in real life, in nature, there are different kind of number patterns that you will come across. For example, you must have heard of the term Fibonacci series. Well, that's a separate topic. I don't want to go into that. So it's a beautiful coincidence that 8 is always there. First line, there is only 1. Second line, it's a sum of 1 and 2. Third, 1 plus 2 plus 3. Fourth, 1 plus 2 plus 4. 1 plus 2 plus 3 plus 4. Fifth line, 8 multiplied by 1, 2, 3, 4, 5. Sixth line, 1, 2, 3, 4, 5, 6. Seventh line, 8 multiplied by 1, 2, 3, 4, 5, 6, 7. So technically, I have done the concept of part A, which of course I'll show you in a short while. Let's see. So now this is focusing on the same thing which I talked about verbally. Now if I talk about the fifth line, that would be minus 1 square, 11 square, minus 1 square. And the right hand side is pretty simple. Sixth line, 13 square minus 1 square, 8 multiplied by 1 plus 2 plus 3 plus 4 plus 5 plus 6. Seventh line, and now you got the idea. Now it says, using the nth, write down an expression in terms of n to complete the nth line of the pattern. Now, in order to complete the nth line, focus on 3, 5, 7, 9. Again in AP. What is the first term? First term is 3. What's the common difference? Common difference is 2. Tn, I have denoted it by the term k, just like in the previous video. So Tn is a plus n minus 1 into d. 3 plus n minus 1 into 2. Therefore, Tn is 2n plus 1. Therefore, the nth line would be, after the minus, there is a 1 square. And before that, what should be there? 3, 5, 7, 9, 11, 13, 15. It keeps on growing. What does it become? It becomes 2n plus 1 whole square. What would come on the right hand side? On the right hand side, we will have 8 multiplied with 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way till n. So that's how the pattern for nth line is written. I hope you understand the beauty of this particular pair of numbers, and that's how things would come into being. The very last part. Using the nth line of the pattern, show that 1 plus 2 plus 3 plus 4 plus dot 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 all the way till n is such and such. Now, by now you have realized that it has something to do with the second part. If you haven't realized it, that's bad. Well, actually, we all learn. So that is related with the second part. So now look at the working. The nth line is 2n plus 1 whole square minus 1 square. That's 8 times 1 plus 2 plus 3 plus 4 plus dot 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 n. Make the extreme right hand side, that bracket, the subject of the equation. It's all pure algebra. Yes, there was a logic involved. That logic was realizing the fact that in a math question, the parts are linked. The examiner was developing the sense in you that first do this, then do this, and eventually you would arrive at that particular answer. So basically, the sum of all these numbers starting with 1 all the way till n, that can be written as half n bracket n plus 1. So that was the first question that we are focusing in this video. And the second question, slightly of a higher level, that is from November 2015. And let's look at this question. Now, this was a strange question. Not difficult, but strange. It says the first term of a sequence is 13. The following terms are found by alternately adding 4 and 6 to the previous term. The first 6 terms are there. Now let's focus. 13, you add a 4, becomes a 17. 17, add a 6, it becomes 23. Then 4, 27. Then 6, 33. Then 4, 37. Then 6, 43. And so on. Now this is technically not an AP. If you look at it superficially, this is definitely not an AP. But that's what you're going to learn in this video. To think a little bit deeper, improve on your intellect. Let's see how it goes. The first part is just getting started. It's like an appetizer that you order in a restaurant. So it gets you warmed up for the main entree to come. Write down the next 2 terms of the sequence. Part B, write down the value of the term that is closest to 999. We'll come to that on the next page. So this is 4. This is 6, then a 4, then a 6, then a 4, then a 6, and so on. So I've written all these terms down. Now, if I look closely, look at the first, third, fifth, seventh term. Yes, they are forming an AP. So now, closest to 999. So first term is 13. Common difference is positive because the second term is bigger than the first. That's 10. Tn is 999. Apply the formula. Work it out. And what you get is n comes out to be 99.6. Of course, the value of n has to be an integer. So it says closest. So you're not going to round up. You're going to round down because you want something very close to that. That number is 99. But when I calculate T99, what I get is that A plus 99 minus 1, which is 98D. That is 13 plus 98 into 10. That comes out to be 993. But is 993 closest to 999? No. Now, 993 is obtained from those numbers. Well, 13 is the first one. We first add a 4, then a 6. And the pattern continues. 4, 6, 4, 6, 4, 6, and so on. That means the number 993 that I've obtained, I can add a 4 to it. And this comes out to be 997. So therefore, this is the number that is closest to this number. Now, if I look at the second way of doing this thing, that is 17, 27, 37, and so on, in this particular series, I'm using the second term, and maybe I'll arrive at the answer directly. 999 is 17 plus n minus 1 into d. When I work this out, n comes out to be 99.2. Again, n is 99. So T99 is a plus 99 minus 1 into d. So that is 17 plus 98 into 10. That comes out to be 997. Bingo. I arrived at that answer directly. So the number that is closest to 999 is 997. Now, there was one very simple fact which every one of us overlooked, and that the unit digit in all of these numbers in that whole pattern is either 3 or 7. Look at the wordings. Look at the numbers. 13, 17, 23, 27, 33, 37, 43, 47, 53, 57, 63, 67, and so on. It's not going to change. That means closest to 999 would be a number which will have a unit digit of 7. So it was wiser for me to get started with the numbers starting with the 17 series, 17, 27, 37, because 999, is it closest to 993 or 997? It will have to be closest to 997. So that was the trick behind it. Well, you all learn with experience. Now it says, write down the difference between the 91st and the 93rd term. Now, if I write more numbers, again, the simple basic concept. You always have to come to your basic. You always have to come to your roots. So between the first and the third term, the difference is 10. Third and fifth, difference is 10. And I'm talking about difference. That means the absolute value, the magnitude. Bigger minus smaller, smaller minus bigger, that is of least bit concern over here. We are talking about the difference. So T1, T3, T3, T5, T5, T7, T7, T9, the difference is 10. Similarly, the difference between T2, T4, T4, T6, T6, T8, T8, T10 will also be 10. Now it says the difference between 91st and 93rd. This has to be 10. I'm just drawing on a pattern. The difference between T3 and T1 is 10. T4 and T2, that's also 10. Since I'm dealing with odd number values, so T3 and T1 makes more sense. Of course, the answer won't change. So 93rd and 91st, the difference comes out to be 10. Now, let's look at the fourth part. Find the 80th term. Now, 80th term, will it be obtained from first, third, fifth, or will it be obtained from second, fourth, and sixth? Now, hold on to your thoughts for a while. Let me show you a number pattern. 13, 23, 33. This is T1, T3, T5. Now, if I focus on these three terms, they are the first, third, and fifth of a bigger series. But if I just focus on these numbers ending with 3, they are basically the first, second, and third. That means if I need the third term, which is actually the fifth of the whole series, so T3 is 13 plus 3 minus 1 into 10. Again, using the same formula. Tn is a plus n minus 1 into d. And I'll get the answer, which of course will match with this. Now, that is my way of explaining you the bigger stuff. Always start with the basic. Something that you have in your control. Work on it. Understand. Get a formula out of it. That means the first, third, and fifth of a bigger series, among themselves, they are the first, second, and third. Similarly, 17, 27, 37, all the way. And this time it's second, fourth, sixth, eighth, 10th. I could have written these 5 terms, the 8th and the 10th. I know that. It would be 47. It would be 57. But for example, if I need the 10th term, A is 17, D is 10, and here comes the real part. Even though I'm looking for the 10th term, but among themselves, among these numbers ending with 7, this is the 5th term. So n is 5. Therefore, Tn is A plus n minus 1 into D. That is 4 times 10, that's 40. 40 plus 17, that comes out to be 57, which is exactly this answer. Now, what has this to do with part D? The thing is, 80th term is consisting of numbers ending in 3 and numbers ending in 7. Therefore, 80th is like an even number term. 2nd, 4th, 6th, 8th, 10th, dot, all the way till the 80th. That means it's linked with 17, 27, 37. But it's 80th term for consisting of everything. From the perspective of numbers ending with 7, this will be the 40th term. So T80, even number, A is 17, common difference is 10, N is 40, and you will beautifully end up with the correct answer. So Tn is A plus n minus 1 into D. T40 is 17 plus 40 minus 1 into 10. So 390 plus 17, that comes out to be 407. That is the answer. Now the very last part of this question, that is the nth term is 23. Now you should be very well aware that since the first digit is 3, that means this has something to do with the numbers starting with 13. So therefore, first term is 13, common difference is 10, 203 is the nth term. It's the last term of this series. Now it's a simple calculation. Now in all these videos you have seen, it's all about AP. Of course, there's much more flavor to it, but right now I'm focusing only on questions related to AP. So just plug in the formula, everything that we know of, what is unknown, n is unknown, therefore n comes out to be 20. But the game is not over yet. The game is not over yet. Hold for a second. This is 20 terms with even position, the 2nd, the 4th, the 6th. Now look at the simple diagram at the bottom, and I'll end this video at this particular miraculous question. There are 5 pink boxes, and if I want to place 4 triangles in between, that's how it would be. That means 5 boxes plus 4 triangles. How many terms are there altogether? 5 plus 5 minus 1. It will always be 1 less on the inside. Whatever are the number of squares, the number of triangles would be 1 less. Squares starting with square and triangles in between. So 5 plus 4 is 9. If there are 20 squares, because the very first term of the big series is 13. So there are 20 terms ending in 3. How many terms will be ending in 7? There will be 20 minus 1, which is 19. Therefore, all together, how many terms are there? Of course, if you don't believe in it, you have to write it. But of course, that's not very advisable in an exam. So that is 20 plus 20 minus 1, which is 39. Therefore, the answer is 39. So now these 2 questions, they took a lot of energy to explain. And of course, even it will take even more energy to attempt them in an exam. What is the recipe for success? The recipe for success is practice, 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 but with a clarity of mind. Understand few questions in its entirety, and then you will be able to attempt them without any fear. Take care.